And we'll go from current slide here. And we're starting with example 4 today. And if I'm not mistaken, it probably isn't in the PowerPoint. So why yeah, so we're going to use 3. Is that going to give us? Yeah, that'll give us. Okay. All right. Oh man, I can't figure out why these stinky projectors require you to be hooked up to them in order to work. It just is a mystery to me. They should know I want them to work, so why don't they just go on and work? I was afraid the email not being sent had been similar operator problem, but it wasn't. Thank goodness it was a system problem, which is just as big a problem, but not one I could fix. All right. Now, a couple of announcements. I don't know if you remember, last Friday was a strange Friday because I had to make up a class for my 112 class, so I was here rather than Birmingham campus. This Friday, I have a dermatology appointment at 9:15, so I don't know for certain if I'm going to go to the Birmingham campus before 8 when I usually get there, and then leave again at 8:45 to go to my appointment, and then come back probably 9:40 or 10:45 or something like that. I will be back after the appointment. I just don't know what time. The thing I don't know is whether I'm going to go there from 8 to 8:45. It just seems like a waste to drive 30 minutes for be there 45 minutes to drive back 30 minutes. I think I may just work from home or from the office, the doctor's office or somewhere, and just do that rather than coming. I've got to check with my boss and see what he wants me to do. So anyway, that's going to be this Friday. Next Friday, I've been assigned to a committee or team or something that's meeting in Mobile. So I have to get up much earlier, but leave around 7 in the morning, drive to Mobile, hopefully get there before noon so I can find where I need to go. 3-hour meeting, and then drive 4 or 5 hours back from Mobile. So driving 10 hours for a 3-hour meeting, that seems a lot of worth it too, but I've been required to do it. So I will not be on campus at all next Friday. I will be some this Friday, especially the latter part, but the earlier part I'm not sure of. And then the following Friday, I have a doctor's eye appointment, and that's going to be right across the road here at UAB West. So that's at 8:15, so I'll come to campus, then go over there, and then when that's over, I'll probably come back here. If I need to go to Birmingham, I'll go to Birmingham, but I won't know that until closer to time. I'd rather not drive with my eyes all weirded out, but I can if I need to. They're giving deep shade, so it'll be done. And then after that, it's almost spring break time. It's getting awfully close, so I should be here the rest of the time on Friday, so Birmingham campus anyway. All right, any questions before we get going today? Sorry it's taken so long to get going, but let's do it. Whoops, let me get my pen set up. Okay. Now, example 4. Calculators and inverse trigonometric functions. How do you do this? Okay, here's the example, the arctangent. They love this old nomenclature. In my mind, it's pretty bizarre. Of negative 8.45. Okay, number 1, can you even do that? Can you take the arctangent of a negative number that big? Anybody? Yay or nay? Yes, okay, because they told you to, right? Okay, if you think about it, remember, the arctangent operates on a number, gives you an angle as a result, right? So think the other way around, the tangent of that angle needs to be that number. And remember what the range of tangent is? Minus infinity to positive infinity. So for the arctangent, that's your domain, minus infinity to positive infinity. So yes, that's a perfectly legitimate request. Now, how do you do this? I don't know what kind of calculators you have, okay? If you have a phone calculator, that could be even more iffy because I'm not certain the syntax for those. The old scientific calculators, what you would have to do is enter the number first and then the function. Most of the newer calculators, especially, I don't know about yours, okay, the newer calculators, what I call display type calculators, graphic calculators, this one you do the function first and then enter the number. So you have to know your own calculator, okay? The old time kind of calculators, the old scientific calculators, you entered the number first, then you negated it, okay? The newer ones, you hit the minus sign in parentheses before you enter the number. So there's all sorts of variations in calculators. If you'll pull out your calculator, phone, whatever you use, see if you can come up with an answer to that. The arctangent of negative 8.45. Now, where do you find arctangent? Remember, if yours doesn't show an arctangent key, look for a tangent to the minus 1. That's the same key. Usually they're a shift of the button with the tangent key. Okay?
Tan H.
What's that?
Tan H.
Tan what?
H.
Oh, no. That's hyperbolic tangent. That's a completely different ball of work.
I got the right answer.
Oh, no. Throw that thing away. It doesn't give you the wrong answer anymore. Okay.
Tan H gives you the right answer?
Huh?
Tan H gives you the
No, tan H does not work. That's hyperbolic tangent. Look for either tangent to the minus 1 or arctangent. It's right on the same key, probably. Okay, let me see it. Is this a phone or is this a...
This is a cellular device.
Okay. Okay, try the second key. And there it is. All right. Phones are different, okay? They don't show the buttons until you hit the button that's going to show it to you. So how do you know what button to hit? But anyway, does everybody get this using your calculator? If not, I'll try to help you with it. I don't know all calculators, but I can sometimes help figure out some. Anyone can't get an answer? And in the back of the book, in the book, another thing you have to do, make sure what mode you're in, probably before you even do this. Just about everything in the text and in calculus from now on is going to be radian mode. Occasionally you'll find degrees, but most of the time it's going to be radian. So be sure you're in radian mode first, or else you're not going to get the answer. Even though you hit all the keys right, you'll get a different number. So what you get, and by the way, thinking of how a tangent looks, it looks like that. So a negative value here is going to be a negative angle. So you expect to have a negative angle. Of course, with the arctangent, it would look like this. And again, a negative number here is going to give you a negative angle here. Okay? So, and it will be in radians. And I guarantee you, it will not be beyond negative 1.57 or something around there, because that's pi halves, and you'll never get beyond pi halves, not as an answer, because the inverse tangent stays between minus pi halves and pi halves. So this can be any number in the world, but the answer cannot. Anyone not able to get the answer in the text? The answer in the text is negative 1.45 blah, 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 blah. Okay, right? Okay. And that's in radians. Now, if you get something that's something like negative 60 or more, that means you're in degree mode. So change to radian mode. Okay. But if you get something you don't get anything or you get an answer other than this, let me see if I can help you. You need to learn to do your own calculator. Okay? Everybody got it? All right. Let's try the next one. Inverse sine of 0.2447. Okay. Now, again, preferable to be in radian mode. What kind of answer do you get?
0.247.
Okay, 0.24 what? 7? Blah, blah, blah. Okay? That is what the book got. Now, let me give you a little hint. I've said it several times before, and let me say it again. If you're in radian mode, which most of the time we're going to be, and either you got small angle in radian mode or a small value for both sine and tangent, then those numbers are going to be very close to each other. As you see, those are pretty close, okay? Because at small angles, both sine and tangent, and inverse sine and inverse tangent are very close to your identity function, okay? So the values are going to be very close to each other. Now, let me see if I can fly back quickly and show you what I'm talking about. Here's tangent and arctangent. Here's arcsine. Okay, we got them all. See, in this range, that's very close to the identity function. Y is equal to x. Tangent and arctangent, very close to the identity function. Y is equal to x. So your values in radians are going to be very close to the value, whichever. These are the radian values here. These are the numerical values there. Okay, they will be very close to each other because those are very close to the one-to-one line. Okay, so it's not at all surprising that that came out real close. If they're small numbers and they don't come out real close, check something. You may be in degree mode. You may be pushing the button wrong. Anyone not able to get this? Everybody got it? Okay. The last one is arc cosine of 2. What do you get? What? Okay, you can't do it because you think of it this way. This is supposed to represent some angle theta, meaning that cosine theta is equal to 2. Never happen. Cosine and sine never go outside plus or minus 1. Unless you've got a coefficient in front of it, but no, we don't. Arc cosine can never be 2. It's outside the domain of inverse cosine. Okay? You should get some sort of error message. Did anyone not get an error message? That one you don't get an answer. Very good. Any questions on that? There are checkpoints here. Please try to do the checkpoints as soon as you can after class. And if you get stuck, like I had a student, in addition to everything else that was happening at the end of the last class, he said, I couldn't get the answer in the checkpoint. I said, well, did you go to larsonprecalculus.com? How do I get there? I said, it's just a website. You just go there. And so you can always check there first. All right. If no questions, then let's move on to compositions of functions. And this is compositions with inverse trigonometric functions. Okay. Now, a little bit of review here from pre-calculus algebra. We know that for all x's in the domain of f and f inverse, inverse functions have these properties. That f of f inverse, if these two functions are inverses of each other, that means both of them are one-to-one functions, and they're in the right domains and ranges, f of f inverse has got to be x, and f inverse of f has got to be x. That's what an inverse function does. You take the inverse of a function of a value, okay, this would be, your input is X, your output is Y, then the output of an inverse is the input of its inverse, and you're going to wind up with the X again. Same thing here. This is going to give you a Y, and F inverse of Y is going to be X, because these undo each other. So, for trigonometric functions, all that we're worried about here is that your X be in the domain of the right function, or your Y's in the right range too, okay? So for inverse functions of trigonometric functions, for your X between -1 and 1, what are we talking about? Which inverse functions? We're not looking at the board. What inverse function are we talking about? You look at the board. No, what? As soon as you see the -1 to +1, what inverse function are you talking about? Sine and cosine. Okay? So sine and cosine have to be between -1 and 1. Okay? Now, but then when you see minus pi halves to pi halves, inclusive, which one are you talking about? Second?
Tangent.
No. That would be not counting that. With that line, and this included, this rules out arc cosine, because arc cosine isn't between minus pi halves and pi halves, it's between 0 and pi. Okay? So this means to have this, you're either arc sine or arc cosine. But for this to be your y's, you have to be arc sine. Okay? So arc sine, the sine of arc sine of x, okay, when x is between these numbers, that can be done. Then take the sine of the angle that gives you that number, that sine of that number, sine of that angle is going to be the x. Because this was the x that gave you the arc sine of x. That means what angle, this is a number, you're looking for an angle, this will be theta. What angle theta gives you a sine of theta is equal to x. Well, sine of that theta is equal to x. Okay, there it is. You just done it and undone it. And similarly, if you do the sine of y, which these are your angles here, that's going to give you a number that when you do the arc sine of that, you're going to get y. As long as you're in between these ranges of numbers. Okay? Okay. Then for arc cosine, this is going to be the same here, but your y is changed from 0 to pi. So this puts you in arc cosine range. And the arc cosine of x means you're given a number between -1 and 1, and you say arc cosine of that number, that's going to be the angle whose cosine is that number, and the angle whose cosine is that number, you take the cosine of that angle, you're going to get that number, okay? That is exactly what an inverse function does. And on the other hand, if you're doing the cosine of this angle, y, that will give you a number, the arc cosine of that number has to give you that same y, as long as you're in these ranges. And then for tangent, x can be any arctangent. X can be any real number in the world, because that goes from -infinity to positive infinity. So -12,585,216.3. That would, you could take an inverse tangent of that. Okay? But your answer is going to be between minus pi halves and pi halves, never touching either one of them. So that's why you don't have the equal sign like you do here. Huh?
You said always?
Always. Inverse tangent has to be within that range. Okay. So the tangent of an arctangent, this arctangent means there's some angle theta whose tangent is x. That's what arctangent means. And if you take the tangent of that angle, you're going to get x. And this is saying the tangent of y gives you a number, and whatever number that is, as long as the y's are within this, then your arctangent is going to give you that value of y. Okay. I was looking for an angle there. So these are the inverse properties of your trigonometric functions. Notice the good news: no arc cotangents, no arc secants, and no arc cosecants. You can do them, but they're a mess. And I don't know if anyone ever uses them. They do use these days. All right, those inverse properties, do not apply for arbitrary values of x and y. They have to be within those ranges of x and y. Because if you did this, what is the sign of 3 halves pi? Anyone know? Say again? Sign starts at 0, goes up to 1 at pi halves, down to 0 at pi, and at 3 halves pi is.
Oh, is it -1?
Yeah, -1. Okay? So we know what that is. It's a -1. But if you do an arc sine of -1, you're not going to get a 3 halves pi. Why? Because arc sine has to be its input, its output will never be outside minus pi halves to pi halves. Can't happen. So you will get -pi halves, not 3 halves pi. Now you might think of that and say, but wait a minute, and this is really sort of true. 3 halves pi would be, there's 1 half pi, 2 halves pi, 3 halves pi. It's really the same angle as minus pi halves. Okay? So they're not the same value, but they are at the same location.
Can you do that for everyone?
Not quite. When you get to the arc tangents, you are off by 180 degrees, not by 360. So you can't quite do it there. Okay. In other words, the property arc sine of y, arc sine of sine y equal y only when y is between minus pi halves and pi halves. Only. You can't put a bigger or smaller value in there and get that same answer out. You're going to get something in between those two. Always. So this is not valid, that y will not be the same unless you're in that, I want to say range. It's a range of one, domain of the other, within those values. Okay. Now, if you're looking for something that's outside of that, then do what we just did, either add 360 to it, add 2 pi to it, or subtract 2 pi from it, and you'll wind up with that. Tangent, you add pi, or subtract pi. So if possible, find the exact value, the tangent of the arctangent of -5. If possible, find the exact value. What you reckon that will be? It will be -5. Because -5 is in the domain of arctangent. Domain of arctangent are all real numbers. So if you do anything in that domain, you do the arctangent, then take the tangent of it, you're going to wind up with that same value. Sorry, I got hiccups. Okay, how about the next one?
That's in the third quadrant, so it's not in between.
Okay. Yeah, you will not get this value. Is that what you're saying? No, you won't. But what value will you get? Sine of 5/3 pi. Where is that, Waldo? Anybody? Where is 5/3 pi?
Is it pi thirds?
Let's see. Where is 5/3 pi?
It's in the fourth quadrant.
Fourth quadrant. Okay. Then I don't think it'll be pi thirds. Will it? Because the sine of, okay, let's think about this. 5/3 pi would be 1 and 2/3 pi. So 1 pi is over here, and 2/3 pi, sure enough, is in the fourth quadrant. So if you're down there and you're taking the sine of that, you're going to get a negative number. And then if you take the arc sine of a negative number, you're not going to get something in the first quadrant. It's going to have to be the fourth quadrant. So it's negative pi thirds. Should be. Yay or nay? Your calculator isn't telling you that.
I'm not.
Oh, okay. I thought you were using the calculator. Okay. Okay. So my guess you're going to get negative pi thirds. Everybody agree? Got some head shakers. Okay, how about the cosine of the inverse cosine of pi? What you get? Second? Not defined? Why, pi is a perfectly good number, isn't it? It's greater than 1. Yeah, it's a good number, but it's greater than 1. You can only take the inverse cosine of something between -1 and 1. So yeah, can't do it. Looks like a nice official number, but this is another not defined. Okay. All right. Let's see how they did it. Okay, first, -5 is in the domain of arctangent function because the domain of arctangent function is all real numbers. The inverse property applies, so that answer will be -5. Okay? The tangent undoes the arctangent, gives you -5. Okay? Now, in the B case, 5/3 pi does not lie in the range of arcsine function. That's between -pi12 and pi12. So, you've got to get an answer in that range. So what they do is subtract 2 pi from it, or you could have added 2 pi, but that gets you further out of the range. So subtracting 2 pi does give you -pi3. That does lie in the range, so that's where you're going to be. Yes?
For that, I didn't put it in the calculator. I just used the coterminal.
Sorry.
Is that right?
I couldn't hear you.
For the 5 pi3,
Right.
I didn't use the calculator. I just found the coterminal. Is that a correct way to do it?
You did the co-function, is that what you said?
Coterminal. Like where.
Oh, yeah, right.
where
The
it's
coterminal. Yeah, exactly. And that's exactly what you're doing. You're subtracting 2 pi. That's exactly what you're doing. Because if you were down here, which is where you were, then to find the coterminal, you either add 2 pi to it or subtract 2 pi to it from it. Or 4 pi or 6 pi or 8 pi or whatever.
In
Any
that
odd.
case, you don't need a calculator.
What's that?
In that case, you don't need a calculator.
No, you can do it in your head. Okay. Calculators are crutch. No, they're fine to have. But this would give you -pi3. That does lie in the range of arcsine function, so that's what you get. Okay? Because the sine of 5/3 pi and the sine of -pi3, because they're coterminal angles, they're the same angle. They're going to give you the same sine value. So that's why it works. But it has to be the second one because the inverse sine can't work on the other. Okay. So it's -pi3. And the expression cosine of inverse cosine of pi is not defined because inverse cosine of pi is not defined because inverse cosine is only defined from plus or minus 1. And pi is outside that. Well stated. Now, how about, could you have done the inverse cosine of cosine pi? Yeah or nay? Yeah, that's perfectly fine. That would be pi. Okay? All right. That wasn't this one. Remember, the domain of the inverse cosine function is -1 to 1, as is the domain of inverse sine function. It's just the ranges are different. Ooh, last slide. That was example 5. They're skipping 6 and 7, so let's us do 6 and 7. Find the exact value of each expression. The tangent of the arc cosine of 2/3. What? Okay. You tell me what this means. What does arc cosine of 2/3 mean anyway? Can you do it? Yeah. Okay, the reason is arc cosine operates on Any value between minus 1 and 1. And that is between minus 1 and 1. But you tell me what you mean by that. What do you mean by an arc cosine of 2/3? Again, I like to name. Are we talking about an angle or are we talking about a value? Angles are values, so it's sort of a loaded question. Say again? Not degrees, radians, but yeah, an angle. Okay? An angle. You want to name the angle? In 3 notes? No, never mind. Make up a name for the angle. Theta. Why not? Oh, one of my favorites, okay? What's another way to express that? That statement right there. Arc cosine of 2/3 equal to theta. Cosine of theta is equal to 2/3. Perfect. Can you draw me a little picture that says the same thing? I'll draw the first part of it. I'll even draw 2 more little pieces of it. Anybody? That's a pretty ugly piece of it. Okay. There's the other piece of it, or at least tried to be. Right? Not a very good rendition, but you get the general idea. Cosine theta, this is your theta, right here. And you want the x value to be 2 over the y value, the hypotenuse of 3. That's why I did a 3 circle here. Okay? And that's the angle theta. Right? This is value 2. This is value 3. Agreed? Now, can you answer the rest of it? What's the tangent of that angle theta? Because that's what you're doing. Tangent of theta, then. What would be the tangent of that angle? Anybody? How would you approach it? Carefully. Anyone want to hazard a guess? Can anyone tell me the y value? Anybody? Can anyone tell me how to get the y value? What has to be true? Let's just assume by my ugly drawing that's the right angle. Let's horizontal, let's vertical, let's hope that's the right angle. Does that help him? Yes, and how does that go? Equals c squared. What's your a, b, and c?
We don't have an a, so b would be 2, c would be 3.
Okay, so c would be 3, b would be 2, so you have 3 squared minus 2 squared. Say again?
Equals a or b squared.
Okay, here.
Equals a or b squared.
Okay, that'll be your a squared. That's what we're looking for. What is 3 squared minus 2 squared? 5. And that would be b squared, so b has to be the square root of 5. Now can you tell me what the tangent of that angle is? It's equal to what? Square root of 5 over 3. That's an exact answer. Okay? If you plug that in the calculator, you'll get some round-off answer. That's the exact answer. That's what they're looking for. Did I do it right? No. Why did y'all let me say that? Yuck. This thing is so aggravating. Okay. Especially when I make a mistake. Okay. There. What is it? Square root of 5 over what? 2. Y over x, not y over. That would have been the inverse tangent. the sine of that angle. We want to do 10. 2 over root 5. No, root 5 over 2. Still can't talk. Not even looking at it. All right. Got it? You see why? Understood? Okay, let's erase that one, unless someone has a question. Okay, let's do the B part. This time we're looking for the cosine of the arc sine of negative 3/5. Okay. Now, how would you proceed with that? Anybody?
Change the arc sine into sine times theta equals.
Okay. We'll set this equal to theta. Why not? And that is equivalent to saying that the sine of theta is equal to minus 3 over 5. Okay. Now to draw that representation, what is sine anyway? In terms of, say again? Y, okay, over, that's only for a unit circle. The radius, okay. Y over R. Good way to think of it. Where does your minus go? Would that go with the radius or does it go with the Y? Yes, the radius is never negative. That's the hypotenuse, never negative. So it has to go with that. So that means we're minus 3 on Y plus 5 on R. So we're going to draw, see, sometimes I'm better off drawing the circle first and then putting the crosshairs in it, okay? Now we need a radius of 5, so I'll put 1 in the middle and then 2 in here. 1, 2, 3, no, I did it wrong. I did 6. Okay. The middle would be 2.5, so do 2 here and 2 there. That would be something like that. All right. Now, and then the 2 here and 2 there. Okay. So the Y is minus 3. That's down here, and we're assuming that radius is still 5. So here is the angle we're talking about. There is theta. Minus 3 over 5. My drawing really stinks. It's not coming up anything close, but don't worry about that too much. 5, and this is minus 3. So what is your x got to be? Actually, it's not too bad. Thought it was worse than it was. What's your x going to be? Don't think so. 4! Good old 3, 4, 5 triangle, right? Oh, 3 squared, 9, 4 squared, 16, 9 and 16 is 25. That's 5 squared. Okay? One of the favorite, and this, my drawing isn't so bad, that's almost in line. Not quite, close. Not really very close. Sort of. I have that last thing too close to the edge. All right, so yeah, 3, 4, 5 triangle. It's a minus 3, 4, 5 triangle. Okay? Now, what would be the cosine of that then? That same angle theta. For what? 4/5. Okay. So the cosine of that angle theta, which would be the arc sine of minus 3/5, would be 4/5. Okay, because of this figure right there. Okay, so you can move the 4 up here, and then adjustment of the R, x over R is 4 over 5. Perfect. Any questions on that? Does that make sense? Pictures are worth thousands of words, so take advantage of them. All right, there is a checkpoint here on 323, so please do the checkpoint. Excuse me, as soon as you can after class. Let's move on to example 7. Any questions before I erase this one? Okay. Example 7. Write an algebraic expression that is equivalent to each of these expressions. So here we have the sine of the arc cosine of 3x. Now, we want an algebraic expression that expresses that. They tell us in parentheses here, or not in parentheses, off to the side here, that 0 is less than or equal to x is less than or equal to 1/3. And that makes sense somewhat, doesn't it? Because at 0, this would be 0, and you can do the arc cosine of 0. And when x equals 1/3, this would be 1, and you can do the arc cosine of 1. Now, technically, you could have done -1 as well, but they chose just to keep it between 0 and pi-3. And there's a reason for that. All right. How do you think you would proceed? Any ideas? Second? Help somebody. Let's just say it was worth thousands of words. Picture. Draw a triangle. But I'm not too sure how to draw this. I'm going to draw my circle first. That's a pretty ugly one. Then draw my crosshairs. Okay. Now, this will be some angle theta, right? Or some other angle, whatever you want to name it. And what's another way of expressing that? Equal 3x. Okay. Now, since I don't have a ratio there, I want to make it a ratio. So what could I put it over? 1. Very good. Now, I have a unit circle, okay, because my radius is 1, okay. This is really ugly quadrant here, okay, and we are keeping it positive, so we're going to be somewhere in this first quadrant. So let's just make this 3x. We don't know what the x is, but that's going to be our 3x there. That's the adjacent side over the hypotenuse of 1, okay. So this is our angle theta. You could just pick any thing to be the 3x there. Okay? Now, we're looking for the sine of that angle theta. And 3x is going to be this length here. 1 is this length here. What is the sine of that angle theta? Anybody? Okay, we have to find this side of the triangle, and what will that be? Square root of, well, why is it not working? The square root of, it's still not working. The square root of, what? Which would be 3x in parentheses squared, which would be 9x squared, right? Got it. And the sine of that would be that over 1. So this thing up here, sine of arc cosine of 3x would then be this thing, square root of 1 minus 9x squared. over 1, but that's all right. You don't have to put it over 1 if you don't want to. That's an algebraic expression that means the same thing as that, with that x being defined that way. Make sense?
1 is the radius for both the cosine and the sine.
What's that?
1 is the radius for both the cosine and the sine.
It's the radius of the circle you're dealing with, because this is adjacent, or x. I want to use x because we've got 3x here. It's the adjacent side over the hypotenuse. Hypotenuse, because that was all you had, it has to be 1. So therefore you're dealing with the unit circle now.
What is that right there when you talk about x? It's the guideline, basically.
This?
What is that?
Oh, that just says that for this to make any sense, x has between to be 0 and 3. Now, it really could have been minus 1/3 to 1/3, but if it's 0, then this is 0, and we know where that is. Adjacent side is 0, that's been up here. If it's 1/3, then this goes up to 1, okay? You can't go any higher than 1, so that's why you have to restrict it to 1/3. You could have gone lower than 0, like negative 1/3, but they chose not to. They just said, this basically puts you in the first quadrant. That's all it's doing. But you can't go beyond 1/3, because then you'd be taking arc cosine of something that's not defined. If that was 2/3, that'd be arc cosine of 2, and we know that doesn't exist. So this keeps it something you can deal with. All right, so that was the A part. All right, for me to erase it. Any more questions on that? Okay, let's do the B part. Okay. The cotangent of the arc cosine of 3x. Why did I erase my thing? Why didn't you keep keep it? Okay. Well, that was ugly anyway. So let's see if I can do a better circle. A little bit better, not much. Okay. And again, you're doing 0 is less than or equal to x less than or equal to 1/3. That keeps that from being out there. So everything else was exactly the same. Let's just pick some value here and let that be 3x. Okay? Okay. And this would be your angle theta if this is theta, just like we did before. Right? And this would be the square root of 1 minus, and that would be a 1 as before, 1 minus 9x squared. Okay. Now we're looking for the cotangent of that angle. What in the world is the cotangent?
It's the reciprocal.
Second?
It's the reciprocal of tangent.
Okay, and what's the tangent? Yes, or y over x. Yes, exactly. So this would then be x over y. And we know what the x is. 3x over y, the square root of 1 minus 9x squared. So we didn't have to draw a new thing. We could have used the one we had last time. That's what this expression stands for. Okay? Any questions on that? You see how to manipulate those things. Set that up to be an angle theta. Then with that angle theta, when you redraw it, rewrite that, cosine of theta is equal to 3x. Then that gives you a, since it's 3x over something, it has to be 1. That gives you, puts you on the unit circle. You know the x value is 3x. Horizontal value is 3x. Vertical value would have to be 1 minus 3x squared, which is 9x squared, and then divide by, then do your cosine, cotangent is adjacent over opposite. Okay. That finishes the section. There is a checkpoint. Please do the checkpoint. So let's do the vocabulary, top of page 324. not everybody has books, so let me clear the screen here. All right. Here's your function. Y is equal to the arc sine of x. All right. Now, first it asks for alternative notation. What would that be? Sine of, no, I don't. You're right, that is what they're asking for. No. Huh. I guess that is what you're asking for. Okay, sorry. Yeah, sine to the minus 1, y is equal to sine to the minus 1 of x. Okay, that's the alternative notation. What's the domain of that x? What values can x take on? Second?
Greater than -1 and less than.
Yeah, okay. -1 less than or equal to x less than or equal to 1. Perfect. And what's the range of that y then? Negative pi halves. Oh, they give you that, don't they? Yeah. Negative pi halves. I could still ask you, okay, less than or equal to y, less than or equal to pi halves. Okay, perfect. Okay. Secondly, they give you the alternate notation of y is equal to inverse cosine of x. Y, yeah, is equal to inverse cosine of x. Okay. What is the function in the old notation? Arc cosine x. Okay. What is your domain for the x there? Say again? Yeah, -1 to 1. Same as sine. Okay. What is your range of the y? Same as sine? Please say no. Okay, what would it be? Zero to pi. 0 less than or equal to y less than or equal to pi. Perfect. Okay. Number 3. Y is equal to arc tangent of x. Alternate notation. Tangent to the -1 of x. What is the domain of the x? Yes, minus infinity less than x less than positive infinity. The way they've done it, all real numbers would work too. I've got his teeth. Thank you. Thank you. What's the range of that y? Negative pi halves. Less than, not equal to, less than y, less than pi halves. Because that's a asymptote that will never reach. Okay. And this, they had you answer both of those. Okay, number 4. A trigonometric function has an blank function only when its domain is restricted. Inverse function. Perfect. Homework exercises. Any of the odds 5 through 17. They're all at Calc Chat. 5's at Calc View. Do 19. It's at Calc Chat. Do any of the odds 21 to 35. They're all at Calc Chat. 21's at Calc View. Do 37. It should be at Calc Chat. Do any of the odds 39 to 43. They're all at Calc Chat. 39's at Calc View. Do any of the odds 45 to 49. They're all at Calc Chat. 45's at Calc View. Do any of the odds 51 to 61. They're all at Calc Chat. 55's at Calc View. Do any of the odds 63 to 71. They're all at Calc Chat. 65's at Calc View. Do 73. It's at Calc Chat. Either 75 or 77. They're both at Calc Chat. 75's at Calc View. Any of the odds 79 to 83, they're all at Calc Chat. 83 is at Calc View. Any of the odds 85 to 89, they're all at Calc Chat. Do 91, it should be at Calc Chat. Do any of the odds 93 to 97, they should be at Calc Chat. And then you're going to be docking a boat for 99 and or granular angle of repose, whatever that is, 101, and or photography 103, and or, so any of the odds 99 through 105, okay? They should all be at Calc Chat. 106 is, and 107, no, I'm sorry, 107 and 109 are true false. They should be at Calc Chat. 111 and 113 are, hey, I said we're going to avoid those, but there they are, inverse cotangent and inverse cosecant functions. Yuck, okay, but you can do those if you like. Evaluating some of those, 115 or any of the odds 115 to 119. We didn't do any of those, so you don't have to if you don't want to, but it might not be a bad exercise to think through them. And then any of the odds 121 to 125. Again, they're the arcsecants, arccosecants, and so on. Another few problems, 127 and or 129 you can think about doing. All right, I hear packing up. Does that mean the time has come, the walrus said? Yeah, I guess so. So we'll start next time, 4.8. Hopefully we'll get through most of 4.8. It's not that long. Hopefully we'll get through most of it. I'll try to have your test ready, so even if we don't get through it, you can at least have the test for the weekend. I know that would throw you no end, right? Good deal. It's good to see papers coming in. Good deal. Thank you. Okay. Good deal. That's coming in too.
Can we email the paper to you, sir? Or is that,
What's that?
can we not email the paper to you?
You can, but whatever comes off, that's what I grade. So sometimes I get email papers and margins are all screwed up, or what you gonna call it, the formatting. What do you call that? Justification screwed up. People just don't pay attention to it. And if they print it, they say, oh, no, that's not what I want, you know. So it's up to you. I will accept them, but I'll grade what I get. And I forgot to show the answers to example 5. Oh, we had already done example 5. That was example 6. Okay. So we were right.
That recommendation letter I was asking about.
The what?
I asked you about a recommendation letter like a few weeks ago.
Yeah, I couldn't remember later which one of the students asked me. So, yeah. When do you need it by?
I thought I saw the deadline's April 15th, but as soon as you can would be nice.
Okay, that would be good. Okay. Normally I'd say I would do this Friday.
Yeah.
Because I usually have some time, but my Friday is now sort of shot. I will try to do it tomorrow morning.
Okay.
But because I got 2 hours of office hours then, and that's just going to be, but I'm glad you resaid something, because I knew someone had asked. I kept saying, who was it that asked this, you know, because I'm teaching 9 classes, and I just could not remember. So I'm glad you said something. But now tell me again, which is this for?
It's for, I believe, just academic scholarship.
Academic scholarship here, okay. Because somebody else asked me for one for honors college, I think. And then I had it crossed up and said, okay, I think I've got 2, but they're different things, so that's why I asked you. I want to make sure yours was an honors college. Yours is academic scholarship. Okay. Okay, I'll try to get on that. I have 0 time today, but I'll have a little time tomorrow. Okay. But keep reminding me, okay?
Okay.
All right.
If you did.
All right, you too. Thanks.